Welcome to MSBTE online learning program, Learning at Your Doorstep. This is Professor Pankaj Dadich from Guru Gobind Singh Polytechnic, Nasik. Continuing our discussion on 8051 memory and I/O device interfacing. Let us see the learning objectives and key learning for this presentation. We will describe the interfacing of ADC 0809 with 8051 microcontroller. After this session, students will be able to state the terms related to analog to digital converter, calculate step size of various ADCs, list specification and application of ADC, sketch interface of ADC with microcontroller, write ALP to interface ADC with microcontroller. Now let's see the concept map for this presentation. 8051 can only process digital data, but real life has analog inputs, so we need an analog to digital converter. Some basics of analog to digital converter. They are semiconductor devices that are using for converting analog signal to digital code. An analog signal has continuously changing amplitude with respect to time. On contrary, a digital signal is a stream of zeros and ones. ADC maps analog signal to binary equivalents. To do this, we have various methods. There is flash conversion, slope integration, or successive approximation. There are different types of ADCs that are available: serial ADC and parallel ADC. Some terms related to ADC. An ADC has n bit resolution where n can be 8, 10, 12, 16 or even 24. Higher the resolution, smaller will be the step size. Step size is the voltage difference between one digital level to the next. So for example, from 0 to 1. Formula for step size is equals to Vmax minus Vmin divided by 2 raised to n, where n is the number of bits in an ADC. Step size for ADC can be given as V reference divided by 256, as 0809 is an 8-bit ADC. Specification for ADC 0809. It is an 8 analog channel with multiplexers. So these are the 8 analog inputs. It has 8-bit resolution. It has low conversion time of 100 microsecond, low power consumption of 15 milliwatts, then 5 volt supply voltage, single polarity. It has high accuracy. Output is TTL compatible. Very easy to interface with microprocessor and controllers. 0 to full scale adjustment is not required. The pins of ADC for circuitry purposes. Now it has 8 multiplex analog inputs from IN0 to IN7. Select lines and ALE. There are 3 select lines ABC to select any one of the inputs which will be converted to output. So total 8 analog inputs can be converted to ADC, but at one time only one can be converted to digital and given to microcontroller. So that is done using this table. ABC as select lines, selecting respective analog channel. D0 to D7 are output pins to give binary equivalent for analog value. Clock ADC does not have an internal clock, so we need to operate using an external clock. When connecting to microcontroller, the microcontroller clock can also be connected to the ADC. We reference the upper and lower limits of voltages to determine the step size for conversion. SOC, start of conversion, to indicate the conversion has started. End of conversion, ADC sends a low to high signal to indicate end of conversion, and for microcontroller to extract the data from 8 pins. Output enable sends a low to high pulse to ADC to extract data from its data buffers. Then ground and supply pins. Students can now attempt MCQs from set 1. Let us sketch the interface of analog to digital converter with 8051. This is the ADC, which has input lines from IN0 to IN7, and IN1 is connected to a input signal. In this case it is a pot. Now the selection of which input line is done using ABC, and ABCs are connected to port pin 2.2, 2.1 and 2.0 respectively. Whichever channel is selected, whichever input is selected will be converted to digital, and that data is given to microcontroller from D0 to D7, and that is on port 1. SOC or SC will indicate the start of conversion. A low to high pulse is given, and EOC will indicate the end of conversion, which is connected to port 2.7. Output enable pin will indicate the data should be read on this port. As ADC does not have an internal clock, the clock is shared with the microcontroller. Let us see the steps to program ADC. First, apply analog input to one of the channels. Then select the channel using ABC. Activate ALE by using low to high pulse. Activate start of conversion by using low to high pulse, and monitor the conversion by monitoring EOC. Once conversion is finished, we get high to low output. That indicates that data is ready to be picked by microcontroller. Then output enable is activated by low to high pulse. That will bring the data out of the ADC chip. And repeat step 2 to 7 for next conversion. This is the program for interfacing of ADC with 8051. These steps are initializing steps. So output enable pin is OE, which is connected to 2.5. Start of conversion is connected on pin 2.6. End of conversion is on 2.7. These are the select lines A, B and C connected to 2.2, 2.1 and 2.0. Port 1, where we have connected the ADC, is given name as my data. These are all initializing steps. We start the program from origin 00H. First, we make port 1 as input port by giving value as FFH. So all bits are set to 1. Then EOC is made high, ALE is cleared, SOC is also cleared, and O is also cleared. OLE will be again kept 1 when we have EOC as 0. Now first we select the channel. So 001 will select channel 1 as input was connected on channel 1. A delay is called. Then ALE is set. This delay is required because we are sending a pulse. So there has to be a delay. Same, SO is also set to start the conversion. Now ALE is cleared and SOC is also cleared. So this will create a pulse. Low, high, and then again low by clearing. Now we will keep monitoring the EOC till the conversion is done. So once EOC is low, it was set here. Now when EOC becomes low, that means conversion is over. Then OLE is set to get the data, to fetch the data from chip to microcontroller. So data is moved from port, that is my data, to accumulator, and again OLE is cleared, and for the next conversion we jump to back. So this is a program for interfacing of 809 ADC to microcontroller. Students can now attempt MCQs from set 2. Applications of ADC, they are used together with transducers, used in cell phones, microcontrollers, digital signal processing, DSOs, digital storage oscilloscopes, in major scientific instruments, and music reproduction technology. Points to remember from our discussion: calculation of step size for ADC. One input line is selected using select lines ABC. ALE needs to be activated. SOC and EOC to indicate start of conversion and end of conversion of digital data. Output enable to fetch the end of conversion and get data from the chip to microcontroller.